Again, the question reads, the force of repulsion that two like charges exert on each other is 5 newtons. What will the force be if the distance between the charges is decreased to a quarter of its original value? So we have that 5 newtons there, and then we are told that we are going to decrease the distance, and then they are asking you to calculate the force between those two after the distance has been reduced. Just like last time, I explained this, I think so well. Can I please have someone who can just volunteer to quickly give us a picture of what is needed here? One other thing, I won't be seeing my screen. So for those who will be wanting to raise their hands, I might not even notice you because my screen will not be visible here. So please, if you have something that you want to say, just go on and say. Thank you. So no one wants to talk.
I think we are looking for a force after the distance has been decreased by that chord. So to our R, we will have 1/4R, and then we will square it. And then we can find the force. Yes.
Okay, thank you. Okay, what does the principle say when we increase the distance? What happens to the force? I'm asking the whole class.
I think the force will decrease.
Thank you. So yeah, when you increase the distance, the force gets smaller and smaller and smaller. So in this case, since we are going to reduce the distance to a quarter, what it means is that if the initial force was 5 newtons, you're expecting something big, okay? So this is how it's solved. So again, as usual, I'm going to use black. Can you see this?
Yes, sir.
Yes.
Okay, thank you. So here what is happening is that you are told that the force of repulsion between two particles, let me make it a little bit big, man. Let me use a highlighter. Okay. Black. So again, as I have explained it last time, we said you have a particle on this point and they've got another one here. And then there is a distance between these two. This one here and is said to be R. Then you are told that F in this regard is equal to 5. Oops, don't mind my handwriting. Then you are told that now we are going to reduce the distance between the two particles. So what it means is that you are going to have your particle here and the other one is going to be here. You can see now that the distance between these two particles is reduced. So what it means now is that your R here is going to be a quarter. So we're going to have a quarter of R like this. So the formula that you used for you to be able to get this 5 newtons that is given to the question is this one over there, where you said the force that can be exerted between the two particles or the two charges is given by K Q1 Q2 over R squared. So you used this formula to calculate these 5. Now, you are also going to use the same formula now to calculate the new force. But the only difference now is that the R that you used to have at first time is no longer this. For the second time, your R is going to be a quarter, like this one. Okay? Can you guys hear me?
Yes.
Yes.
Can you hear the noise at the background?
Yes.
Okay, it's fine. I think it's the noise is gone now. So what I was saying is that when you are calculating your F for the first time, which you can call F1, you use the normal R, and the answer that you are going to get is the one that is given on the question. Now when you are calculating for F2, F2 now is the force after the distance has been reduced. What changes is the R. So your R now it's going to be a quarter of R, then you square that. And when you square that, that's when you get something like this as your denominator. Then when you get something like this, we always said that when you are dividing a fraction by a fraction, you invent. So what it means is that this 16 will end up being on top as a numerator like this one. Then you will find out that this whole thing here, this one, is equivalent to this, which is also equivalent to 5. So in place of all this F, you are going to, in place of all this, you're going to put the value of F1, which is 5. So at the end of the day, you have 16 multiplied by F1, which is 16 multiplied by 5. Then you get 80 newtons. Do you guys get it?
Yes.
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 Yes, sir. Yes, sir.
Yes.
Yes.
Okay. No question, no whatsoever.
Is it different when they say that if the distance between them is increased? Like, is there a difference between increased and reduced in terms of
Sorry,
calculations?
you were breaking. I didn't hear the other part.
If they were to mention that it's increased, the distance between the charges is increased instead of reduced, is there a difference in signs, or it's just a
Okay.
word?
Thank you. When they say the distance between the charges is increased, né? What will simply happen is that they will tell you maybe the distance increased maybe by. Usually if it's increasing, they will tell you it increased by maybe 2 times or by 3 times or by whatever it's going to do. So what you simply do is that you multiply whatever the value that you are going to be given by R. Are you getting what I'm trying to say?
Yes.
Yes, you just multiply by R. There's nothing that is going to happen to the sign. What is simply going to happen is that your R, you are going to multiply. And that whatever that you're going to get after you multiply, then that's going to be your R. Then you can go on and calculate.
Okay.
Okay, let's move on. If they are there other questions? I'll take that as a no.
No, no question, Prof. You can proceed.
Thank you. Yeah, then we go to question B. The question B is saying an alpha particle which has got a charge of 3 electrons, that's plus 3 electrons, is sent at a high speed toward a gold nucleus with a charge of plus 79 electrons. Then they go on and say, what is the electrical force acting on the alpha particle when it is at a distance of 2 times 10 to the power negative 14 meters away from the gold nucleus? So what they're trying to say here is that you've got a particle here, you have another particle there, né? And then the distance between them, this one here, is this. Then the question is, what is the electrical force? So they're asking you for F, né? Where this one is going to be your Q1 and this one is going to be your Q2. But remember, Q is a charge, and this right here, it's a number of electron multiplied by E, which is a charge as well. So you to use this one as your Q1 and this one as your Q2 to find your answer. So you know the value of E. So what you simply do is that, okay, let me bring this one forward so that you guys can simply see. So here, what you can simply do, you'll be knowing the value of K, né? It's given in your start guide. You also know the value of E. It's also given in the start guide. What is the value of E?
1,6 times 10 to the power negative 19.
Thank you. So you put the value of E here. The reason why here you are having E squared, it means you've got the E for particle number 1. As you see here, we are only having 3, of which from the question it's 3E. So one of the E's comes from particle number 1, then the other E comes from particle number 2. So here you have got 3 times 79, simply means these 3 here, and then this 79 here. Then the 2 E's are the ones that you see here written E squared. Then the distance, it's given right there. So if you multiply these, you are going to get the answer to this question. Am I making myself clear?
Yes, Prof.
Yes, Prof.
Thank you so much. So again, units are very important in this module. They should be seen how they cancel each other. They are very important. Thank you. If you guys don't have any other question, we can proceed to the next question so that we can save time. There is the question, folks. 3 charges are fixed to an XY coordinate system. A charge of 15 microcoulombs is on the y-axis. So here now, this is the analogy of what we have. You have a Cartesian plane, supposedly, supposedly something like this. Then they are telling you that a charge of 15 microcoulombs is on the y-axis at y is equal to 3. So we are assuming that this is the point where y is equal to 3, and that's where we have our Q, probably Q1. Then they went on and say a charge of 12 microcoulombs is at the origin. So you have another charge here, and you're going to call that probably Q2. Don't mind my handwriting, please. Q2. And then they went on and say, lastly, a charge of this is on the x-axis at x is equal to 4. So you're going to assume that this is the point where x is equal to 4. Then you put your Q3 like this. So here, they're saying determine the magnitude and direction of the net force on the charge x is equal to 4. So you're asked to calculate net force around this charge here. So what you should know that is that particle number 1, it's a positive one. Particle number 2, it's a negative one. And then particle number 3, it's a positive one. So you have been told that positive, they they repel each other. Then negative, positive, they attract. So what is going to happen around this particle here? Let's start with respect to particle number 1. Since particle number 1, what is positively charged, ne? Is it? Is it? Yes. Particle number 1 is positively charged. So particle number 1 is going to force particle number 3 to repel like this. So here you are expecting to have the force that we can say F, what? The effect of force 1 on force 3. Ne? Then particle 2, this one, it's negatively charged. So since it's negatively charged, it's going to be attracted. There's going to be a force of attraction. Since this one is positive, this one is negative, they're going to attract each other. So you have something like this. You have a force going this side and this one here. And we are expecting to call this force, it's a force of the effect of force number 2 on force number 3. So you can write it the way you want. So at the end of the day, this is what you have. This thing over there, that's what you have. Folks, can you see what I did here?
Sorry, sir. Q2, I think Q2 is positive.
Q2 is positive, sir.
Q2 is positive.
Yes.
And Q3
Okay,
is
sorry.
negative.
Okay, let me read again from the question. Thank you so much for that. Ne? So here they are saying a charge of plus 15 is on the y-axis, which means it's positive. A charge of plus 12, oh, sorry, thank you, I didn't see this, is at the origin, which means this one again is positive. Thank you so much. Ne? This one is positive. Let me erase. Okay, so this is what we have. We have our Q1 here. Q1, which is positive. We have our Q2 at the origin, as the question said, which is also positive. So that's your Q2.
You can see the slide.
Huh?
Did you remove the slide so we can see it?
Guys, can you confirm if you can't see, all of you?
Yes, we can see the slides.
Oh no.
Yes.
You can't see anything?
No.
Yes, because the
Something.
in progress.
I can't hear you.
The screen says return whiteboard in progress.
It says something went wrong.
Mabuya. Okay, I get it. Sorry. Now,
we can see now.
thank you.
You can see that.
Everyone, can you confirm? Thank you. I think my network was acting up. Now my slides don't want to move. Yo, Okay. Let me remove these junky things. Okay, can you see?
Yes, sir.
Yes, sir.
Okay, thank
Yes,
you.
sir.
So I was drawing a Cartesian plane. During that time, it was beautiful. Now, I don't know what's coming out now. But for emphasis sake, it's okay. So we were having a particle number 1 somewhere here, which we said Q1. And you and I agreed that Q1 is positive. Then we were having particle number 2, which we said that's Q2. And you and I agreed again that Q2 is positive. Then we were having another one here, which we said that's Q3. And you as a class, you said Q3 is negative, right?
Yes, it's negative.
Good. So it's going to be negative like this. So now we are going to look for the effect of Q1 on Q3, because this is the particle in question. The question is saying, determine the magnitude and direction of the net electrostatic force at x is equal to 4. So that means at particle number 3. So the effect of force number 1, of charge number 1 on charge 3, since they are opposite charges, you have got a positive here, you have got a negative here, so you expect to have an attraction. So this is going to be attracted to this particle. So here you are going to have the influence of force number 1. Influence of force number 1 on force number 3. Then we look at force number 2 with respect to force number 3. Again, we have a positive here and we have a negative here. So there's going to be an attraction again to this direction here. So at the end of the day, this force here, it's an influence of force force 2 on particle number 3. Sorry, it's the influence of charge 2 on charge number 3. So you have something like this at the end of the day. Are we clear so far?
Yes, sir.
Yes.
Thank you. So bearing in mind that this side here, this one, it's 3. This side it's 3, and this side here it's 4. You should go with these figures in your mind. So you've got 3 here, and then you've got 4 here. But you do not know this one. This one over there, up until you get to this point. This one, you don't know it. So you simply call it R. Are you guys getting what I'm trying to say?
Yes, sir.
Yes,
Good.
sir.
Yes, sir.
So this is going to be your R, and then you are going to have an angle that you are going to call theta here. Theta. How do you get the theta? You have got the opposite here, you have got the adjacent there. So you use tan theta. Is that fine? So tan theta will help you to get the angle. Then to get R, you can use Pythagoras theorem. You've got the opposite, you've got the adjacent. So what I'm saying, ladies and gentlemen, is depicted here on what was being worked on this. So this is the 4 that I was talking about. This is the 3 that I was talking about. This is your Q1. And so this one is going to be your F2 on particle number 3. This one is going to be your F1 on particle number 3. So at the end of the day, you will need to calculate this R, and then you need to calculate this theta here. So for you to get this R, that's what you are seeing here now. R squared, they are using Pythagoras theorem, is given by 3 squared plus 4 squared, and that will give you this one squared. Yeah, that's your R squared. So that simply means that R is equal to 5. Are we together?
Yes, sir.
Good.
Yes, sir.
Now, to find your theta, you use tan rule, which says tan theta is equal to opposite over adjacent, where your opposite is 3, and then your adjacent is 4, and then your angle is going to be 37 degrees. Okay, then when you do that, now you do what we call resolving. Now you need to resolve. What is it that we mean when we say resolving? Remember, you have this force that we said may have F 1 on 3. Then you have this one here that we said f bar 2 on 3. These two. So to resolve now is to find what we call the components. So you are going to have the components in the y-axis as well as the components in the x-axis. But before we do that, since we know this angle here, this one, we want to know the influence of, the relationship between this force, this one, and the angle. We need to know the relationship between these with respect to the x-axis and the y-axis. Therefore, here at the bottom, you expect to have something, and here, vertically, you also expect to have something. So at the bottom, since we know the angle, this side here at the bottom, this one, this side here, with respect to this and the angle, it's going to be F13 cos theta. Why? Because it's sitting, because the angle is sitting on it. So in other words, it's adjacent to the angle. So you're going to have F13 cos theta. Then this side, you are going to have F13 sine theta, the opposite one, F13 sine theta. Sine what. So at the end of the day now, when you say summation of all forces in Y, what do we have? We only have this one that says F13 sine theta, which is this one. Yeah? That's all that you have in y-axis, and it's pointing towards the positive direction. That's why you see there's a plus here. That's all you have in the y-axis. Then we go to the x-axis now. To the x-axis, we have two things. The first thing is this force here, the direct one that is going this side, which is F23. This one. This one. That's your first force. But since it's going to the negative x-axis, that's why you see here it's being written F2. And there's a negative. Simply means it's going to the negative direction. Then we also have this horizontal component, this one, with respect to F13. And that's what you see here being written F1 cos 37. So at the end of the day, you have minus this, and these are going to give you what we need with respect to x. So now, ladies and gentlemen, you need to calculate the value of F13 and F23 using the Coulomb's law, whereby F13 is given by K Q1 multiplied by Q3 over R squared. Then F23 is given by K Q2 multiplied by Q3 over R squared. So you put those values in place of F1 and F2 here. After doing that, then you will be able to calculate Rx and you'll be able to calculate Ry. When you do that now, after getting the value of Rx and Ry, then you come to this formula that we even used to use last semester. For you now to be able to find your resultant or the magnitude, you need to find Rx squared, then Ry squared, that you would have gotten from these values here, ladies and gentlemen, these ones. And then after that, you need to find the directions. So according to what has been calculated, this is what they got. I'm not sure, I didn't verify. So this is what was found as the answer. So let's say you get this and that. So you come and plug these here and there, then you find your Rx and your Ry. Then this one will help you to find your magnitude. Then if you want now to find the direction, which is the angle theta, it's just arc tan. Ry will be this value here, then Rx will be this value here. Then at the end of the day, you will get your answer. Is there anyone with a question?
What is that? Can you please repeat X component?
Sorry? Andikuva kakuhle uthini?
Sorry, sir, can you please repeat X component?
All right. So what I was saying about the X component is that, remember, you guys, when we resolved our diagram, ne? Just forgive me, I want a whiteboard so that I can just try to make a clear emphasis. Remember, we're having a particle here, we're having another one there, and then we're having another one here. So what happened is that this one was attracted this side, and then it was also attracted this side. So now, if you're asked from what you are seeing on the diagram, since we have an angle here, let's say our angle theta, and then you are asked to give us the horizontal component and the vertical component, what you will see. So I'm going to say this one, according to what is there on the diagram. Let's say this one is your F1. I just want to make to use simple things so that I can explain it pretty quick. Then this one is F2. Let's say this is what you have. Remember, this F1 here is acting at an angle, which is theta. Therefore, what it means is that there is a horizontal component and a vertical component with respect to F1 and theta. So for you now to be able to do that, you need to resolve. When we are resolving, we are completing this triangle here, this one. Now, after completing this triangle, you have got your F1 here and your theta. So this side that you have here with respect to F1 and theta, it's going to be F1 cos theta. And then this side that is opposite, this one, with respect to F1 and theta, it's going to be F1 sine theta, like this. So now, when you're asked to calculate the summation of all the forces that are acting in X, let's start with those. You will find out that you have got this force here, this one. And remember, this one, it's because of F1 acting at an angle. That's why we've got this horizontal component. So the first force that we have, it's F1 cos theta. But since it's going to the left side, it's going to be negative F1 cos theta. Then you also remember, you also have this one. This one has nothing to do with F1. F2 is standing on their own. They don't have anything to do with F1. Therefore, you also have to include F2. So you also have negative F2 here because it's also going to the left. So if these forces are to be dealt with, this is what you have in your horizontal component. Now, in your vertical component, summation of all forces in Y, it's going to be given by, you only have this one. That's the only force that's acting in Y. So it's going to be F1 sine theta. Then you need to find the values of F1 and F2 by using Coulomb's law. Since F1 is the force acting, is the effect of charge 1 on charge 3, it's going to be F13. So you're going to multiply Q1 and Q3, then K, then the distance, then everything. Then when you are done with that, it will help you to get the value of Rx and Ry. Then you do this whole process. Did I answer you?
Sorry, sir, I have a question.
Okay, just wait a little bit. I want the previous speaker to confirm if they got me or not.
I think I got you, sir.
Don't think. I want you to be confident enough. Did you get me?
Ah, yes, I got you.
Thank you. Yeah, you can go on.
Oh, okay. Say on the component method, using our teachers, we start from the positive x-axis, right? So we start from the positive x-axis, right, to cover our theta. Are we still using the angle that we find for theta, or we are subtracting it from 180?
Right. The situation that we have now is kind of different from what we used to have when we were dealing with those component methods last time. Because right now what we have now, we have a triangle, this one. And I'm going to make it easy for you. And if you look here, you have 90 degrees. Yeah? And here you have got 3. And here you have got 4. Like this. So using whatever the method that you are going to use, you will find then that this angle is going to give you 37. And this one is going to give you a certain number. So there is no way this angle can be subjected to the quadrant rule. I'm not sure if I have answered you correctly or not.
Thank you.
Did you get me?
Yes, sir.
Okay, thank you. Do we have any other person with a question before we go forward?
No questions. Let's go, sir.
Thank you. Just master the idea. The questions, even the ones that are going to answer tomorrow, they are almost the same like this. You just have to master the idea. Okay, with that being said, we have a question here. If Q is equal to that, Q is equal to negative 16 microcoulombs, and then A, which is the distance between these two, A here is said to be 3, and B is equal to 5. You have got B here, and it's said to be 5. Then they are saying, what is the magnitude and direction of the electric field? You should master these words, folks. The difference between electric force and electric field, you should master that, because you can go on and calculate F when they need E. Okay? So here what they're asking you to do is that calculate the magnitude and direction of the electric field at point P. At point P here. So we know most. We know we are given that Q is equal to negative. So this value of Q, they are all negative. And I've said it before that the point charge, which is the point P, whether it's given to you or it's not, you should know that it's always positive. I made it clear last time. So what is going to happen, since our Q is going to be negative, this one, our point charge with respect to what? To Q here, it's going to be attracted. Then our point charge with respect to this one again, it's going to be attracted. Then our point charge with respect to this is also going to be attracted. So at the end of the day, you have your E, let's say E1 here, your E2 here, then your E3 here, like this. So let me bring in the diagrams. So this is what you have at the end of the day. You have something like this. So the point charge, they are not going to tell you that it's positive. The point charge is always positive as long as you are dealing with electric field. That's why you see all these are going to be attracted. So now what is very important is for you to find this direction here of this Q. I'm not sure. Here we called it Q3. So you need to know R for Q3. That's what is important, because R for Q1, it's given as what? As B. Ne? So this one is given as B, and this one is given as A, R for E4. So now when you do that, you simply have to find all the forces that, the electric fields that are acting in x-axis, and then all the electric fields that are acting in y-axis. But still on that, I want to extract this small triangle that you are seeing here, this one. So if we extract this, we have something like this. Where this side here, where this E here, it's E4 according to what has been solved there. This is E4. And then this one is going to be what? Probably E3. Oh, my handwriting. This is going to be E3. So here you are told that the distance is B, and B is what? It's 5. So you have 5 here. And then here you are told that the distance is A, so which is 3. This is 3. Whatever that you are seeing, you have to clean your eyes. This is 3. Right. So first thing first, you need to find the value of R here. After getting the value of R, don't confuse the value of R with the electric force E3. Ne? You need to find R, the distance between the point charge and Q at this corner. That's going to be your R. When you get your R now, you also need to know this angle that we are going to call again theta, like this. So when you do that, now you need to resolve this E here that you are seeing here. Why do we resolve? Because this E is acting at an angle, this angle right there, this one. So this E is going to have a vertical component as well as a horizontal component. So speaking of that, this is what you are going to have. You are going to have a component this side. You are also going to have a component that side. I'm sure it's visible. So the component that you are going to get this side, that's going to be your horizontal component. Then the component that you are going to get this side, that's going to be your vertical component. So for the horizontal component now, with respect to this angle here, it's going to be E3, since it's opposite, it's going to be E3 sine theta. I don't know which one is going to be your theta, but this angle here, that's the angle that you are going to use, this one. So let's say this angle is what? It's theta. Then this one, we no longer call it theta. Maybe this one is what? It's alpha, just to distinguish the angles. Let's say this one is alpha and this one is theta. So your horizontal component this side, it's going to be E3 sine theta. That's your horizontal. So your vertical is going to be E3 cos theta. Bear that in mind, that it's no longer what it used to be. Now it's a different case. So your horizontal with respect to E3, it's going to be E sine theta. Then your vertical is going to be E cos theta. So at the end of the day, when you're asked now to calculate all the forces, that the electric fields that are acting in the x-axis, you see you have your E1 here. Where do we get this E1 from? E1 is this one that you are seeing here, ladies and gentlemen. This one. That's the first one. Since it's going to the negative direction, that's why you see it's negative. Then you have minus E3 cos 37. I said it that this one here, where is it? This one, okay. What you are seeing here, the person who was writing this had to invent their diagram. So what they did, instead of using this side here, this one that you guys are seeing, they used the other one, the opposite, which is this one. This one. That's what they used, which means automatically this one is going to be their vertical one, and this one is going to be their horizontal one. But what will change now is the angle. The angle that they are going to use this time around is going to be equal to this angle here. Why? Because of this Z. So now they are going to use this angle, and that angle is going to be this one. So whatever that they are going to do, this one is going to be their horizontal component, and this one is going to be their vertical component. So with that being said, since this line here is our E3, so E3 with respect to this side, it's going to be E3 cos theta, this angle here. It's going to be E3 cos this angle. And then this side with respect to E3 again is going to be E3 sine this angle. So that's why you see here, they took our E1, which is this side, then they came in and say E3 cos 37. This is the side that they used, this one. Yeah. So at the end of the day, they will be able to get their EX. Then for the forces in Y, they took E4. E4 is this force that is going down, this one. That's E4. According to the diagram, this is E4 here. So they take it and it's going to be a negative because it's going down. That's this one. Minus E3 sine. Again, it's this side that I was talking about, this one, which is this one. Yeah. Remember, we resolved with respect to E3. So it's going to be this side. Since this side is facing down, that's why you see here it's negative E3 sine 37. So you'll be able now to calculate your EY. And then when you do that, you have to find the value of E1, E3, and E4. After doing that, then you substitute in these values here, this one, and this one, so that you can find the value for this and that. And when you do that, then you come to our normal formula here, which says this will be equal to that and that. Then you find your value. After doing that, then for you to be able now to find the direction, it's again the same thing. Then you get your direction. Do we have any question? Direction. Huh?
Sir, may you please repeat how we find the E4?
E4. Okay. What I was saying is that if you look at this point P here, you will see that since all these are negative, they are going to be, the P value is going to be attracted either sides. It's going to be attracted here. It's going to be attracted there. It's going to be attracted again here, like this. So this is how they were named. This one was named E4. This one that is going down. And this one was named E3. And this one was named E1. Right. So before you go any further, you need to find the value of R here and the value of this angle here. Ne? So to find that, you can complete this triangle. I want to use the exact method that was used here so that you don't lose me. This side, you are told that it's A, which is 3. And this side, you are told that it's B, which is 5. This one is B, which is 5. So you've got your 5 here, you've got your here. You can be able to find this angle, ne? By using what? Tan rule again. Tan theta is equal to opposite over adjacent. Opposite over adjacent, then you can find the value of theta here. After getting theta, you have to resolve this force, which is E3. So you need to find the components of E3 with respect to theta. The first one will be this side here at the bottom. This one that you are seeing this side here. It's going to be E3 cos theta. Why? Because it's adjacent to this angle. So it's going to be E3 cos theta. This one. E3 cos theta. Then this side here, this one, it's going to be E3 sine theta. It's facing down. It's going to be E3 sine theta. When that happens, when you are coming now here to calculate all the forces that are acting in X, you first pick E3. Why? Because E3, that's the force of Q on P. This force here, that's the first thing that you take. You take E3. That's your E3 here. Since it's going to the negative direction, That's this one. Then this one that is saying negative E3 cos 37, it's the horizontal component of E3, which we said it's E3 cos theta. This one. That's what you see here. Again, it's negative because it's going to the left side. Then you'll be done with your electric fields in x-axis. Then your electric fields in y-axis. The first one is this one, which is E4. That's why you see it's being written negative E4. Then the second one is the vertical component of E3, this one over there, which is facing down. And we said it's called E3 sine theta, this one. So that's why you see here them writing minus negative E3 sine theta. And then when you need to find now the value of E1, the value of E3, the value of E4. And when they calculated, they found that the value of E1 was this, the value of E2 was this, and then the value of E4 was that. And then you substitute these values here for you to be able to find your EY and your EX. When you find your EY, then you substitute in these unknowns here, so that you'll be able to find the E resultant, which is the E magnitude. Then for direction, after finding your EY as well as your EX, then you can be able to find your direction again. Does it make sense now?
Yes, it does.
Thank you. Everyone, are you getting me?
Yes, sir. Yes.
Yes, sir.
Yes.
Is it clear, guys?
Yes, sir.
Yes, sir.
Thank you. Thank you so much. So let's go to the next question. So here, the points to take are that a point charge is always positive. So it is the point charge usually that is attracted or repelled. Okay? The point charge is the only one that is attracted or repelled when we are dealing with the electric field. I think I made it clear. Right. We have another question again. The question says a charge of that is fixed at the origin. Okay, we also have a Cartesian plane again. Right, a charge of that is fixed at the origin. So what it means is that it's here. And you can call it Q1 if you want. Is fixed at the XY coordinates. Then a second charge is at X is equal to 3 and Y is equal to 0. So it's somewhere here. You can call it Q2 if you want. And then a third charge, which is this, is at X is equal to 6 and Y is equal to 0. So you can put it here and then call it Q3 if you want. Then they are saying, what is the magnitude of Q if the resultant field at X is equal to 9? Since this one was X is equal to 3. Okay, let me put the values. Here you have got 3. Here you've got 6. So I'm assuming that 9 is somewhere here. They are saying, what is the magnitude of Q if the resultant field, what is 30 newtons per coulomb and is directed to the left? So probably you have your E somewhere here at X is equal to 9, and they are saying it's directed to the left. It's going this side. So this is easy. You need to calculate E1, the effect of Q. You need to calculate E1, which is the effect of Q1 on what? On the point charge that is here. Ne? Are you guys there?
Yes.
Yes, sir.
Good. So you have, let's say you have your point charge here. So your E1, the effect of E1, since E1, we are told from the question that E1 is positive, is going to force what? The point charge to go this side at a distance of what? What is the distance for E1 with respect to the point charge? Folks, what is the distance for Q1 with respect to the point charge?
It's 9, sir.
I think sir.
So yes, thank you. It's going to be 9. That's your Q1. Then Q2. Q2 again is positive. So it's going to have the same, but now the R will reduce. What's the distance of Q2 with respect to the point charge? 6. 6, ne? Thank you. 6. Then we have Q3. Q3, the distance will further decrease. What will be the R for Q3?
3.
3. Thank you. So you have your 3 here. So you calculate your E1, E2, E3, and E4 if there is E4. So we know the formula most. E is equal to KQ over R squared. You have got the value of Q, you've got the value of R, you know the value of K. So you can calculate your E1, your E2, and your E3. When you do that, you have to do the summation of those. So you need to have E1 plus E2 plus E3. They are going to be equal to negative this value that is given here. They told you most that the magnitude is 30 newtons per coulomb, but it's going to the left. So the fact that they said left, your E summation is going to be negative. So what I'm saying, ladies and gentlemen, is what is here. Is what is here. So you need to calculate your E1, and you need to calculate your E2, and you need to calculate your E3. And then your result, you equate it to negative 30, because they said it's directed to the left. And then when you do that, you will find then that what is going to be missing here is what? Is the value of Q. That's what is only going to be missing, this Q here, which is this one. They didn't give you the size of the charge, so that's what you are looking for. So from this question, you are looking for Q. So you have to do all the math. There, you simplify. So when you get to this stage over there, you make Q subject of the formula. After making Q subject of formula, you come this side, you multiply by 36, then you divide by K. We know the value of K. Then there and there, you'll be able to find the value of Q. Am I clear?
Yes.
Everyone, can you please confirm?
Yes, sir.
Clear.
Yes.
Thank you. So
No,
let's
sir.
move on. We are moving on. Not moving on as in moving on, but moving on. Right. So there you have it, folks. Two positive charges, Q1 and Q2, are separated in a vacuum by a distance of 3 meters. So you have got your Q1 here, and you got your Q2 here. That's Q1. Oops, whatever. Then that's Q2. There. And they are said to be separated by a distance of, so the distance that separates them is 3. Like this. Then they are saying, find the spot on the line between the charges where the net electric field is 0. So they want you to find a point between these two. where the net electric field, which is E, is 0. So what they mean, they need a point whereby E1 that you are going to get as a result of this, E1 minus E2 sorry man, E1 plus E2 is equal to 0. That's what they are saying. They want you to create a spot between these two things. And at that spot, these two electric fields, if you sum them up, they should give you a 0. So what you can simply do, folks, along at any space along these two things here, you can come and just mark as a spot. So now I want to come and mark a spot. Okay, let me redraw them here. Then this is the distance between them. So I want to come and mark a spot probably somewhere here. That's where I want to put my point charge. So I'm going to label this P. Simply means the point charge. You have got your Q1 here and you have got your Q2 here. So this is an assumption. So you can simply put a point wherever you want, as long as it's within these two as being advised by the word between here. So when you do this now, since from Q1 to Q2, we know for a fact that the distance between these is 3, like this. Now, what it means is that you will need to know the distance between P and what? And Q2. If this whole thing is 3, so what it means is that you can assume that this distance, maybe it's what? It's X. They usually prefer to use the word, the letter X. So we're assuming that the distance between the point P and the particle, the charge Q is X. Therefore, we also need to know this one, the remainder here, this distance. So if this one is X and the whole distance is 3, what it means is that this one is going to be 3 minus X. So this distance is going to be 3 minus X, like that. So now it's easy now. So you can simply now calculate E1 and E2. So to calculate E1 and E2, let me just bring in what has been solved so that I can explain with something that you guys can see. So yeah, though it's not that 100% clear, but if you kept what I was saying there in mind, you can see where this X is coming from. And then you will know that from this point P, this is the point that was created, P, you have 3 minus X as a distance between the point P here and charge what? Q1. And then this one, the remainder distance here is what is said to be X. So when you do that now, you need now to calculate the value of E1 and the value of E2. So the value of E1, that's what was calculated here. You know most the value of Q, it's given, Q1 is given. The value of K, you know it. Then R for Q1 with respect to the point P is going to be 3 minus X, as I have mentioned. Then since we square that, then you put your square here. Then you need also to calculate the value of E2, which is given by K. The value of Q2, you know it. Then R for Q2, which is the distance between the point and the particle Q2, is X. And then you do this. After doing that now, since we said we need a point where E1 plus E2 is equal to 0. This is what we need. But again, what is it? Technically speaking, this is what we need. a spot where E1 plus E2 is equal to 0. But if you come back to this point here, this point, I'm going to remove what I've been writing so that I can explain a little bit further. So from the point P that we have, you can see that I've said it to you guys that P, the point that we have, is always going to be positive. Because remember, we are dealing with an electric field. So the point P is going to be always positive. So we are going to have the effect of Q1 on P. Since Q1 is positive, it's going to repel the point P towards this direction. That's why you see your E1 is on this side. Then Q2, since it's also positive here, it's going to repel the point to this direction. So at the end of the day, this is going to be your E1, and this is going to be your E2. Now, if you want to find summation of E's acting in x-axis, you will find then that you have got E1, ne? E1. So guys, you've got your E1. Since this one is going to the right, it's positive. Then your E2 is going to the left. So it's going to be E1 minus E2. So now, since they said find the spot between the charges where the net electric field is equal to 0. So they're saying these two must be equal to 0 at that point. So you equate these to 0. So when you do that now, when you find your value of E1, which is this, and then you find your value of E2, which is this, you come and put E1 here, and then you come and put E2 here. So what it means is that since E1 is positive, E2 is negative. If you take E2 to the other side, what you have is that you have an equation that says E1 is equal to E2, like this. This is what you have at the end of the day. So you take the value of E1, then you equate it to the value of E2. Since the value of K, both sides is the same, so K and K, they will cancel each other. Since each one of these is also going to use microcoulombs, so the microcoulombs, they can as well cancel each other. Since 4 can get into 16, so 4 again can disappear this side, and this side you have a 4. So at the end of the day, you have something like this. Have a simplified equation. Okay, they didn't want to simplify, but you can simplify further by dividing both sides by 4. So at the end of the day, you have an equation like this, folks. How did we get there? They cross multiplied. So this multiplied by this, and then this multiplied by this. And then you have an equation like this. Then when you introduce this into the bracket, you end up having something like this. Then you solve this quadratic equation. And then your answers are going to be negative 3 meters, or x is equal to 1 meter. Now, how do you know as to which one are you supposed to choose? So remember, we had a situation like this. You had Q1 here, you had Q2 here, and then you've got a point in the middle, and you were told that this one was 3. This one was 3. So P can't be negative 3. Why? Because negative 3 is not within the range, or is not between these two charges. Therefore, you neglect this one and you take 1. Why? Because 1 is somewhere within the range of these two. Am I making myself clear, guys?
Yes.
Yes, sir.
Everyone,
Yes.
did you get me?
Sir.
Yes, sir.
Thank you. Let's go to the next question. Right, this one we did it last time again. The question says 2 particles with identical or same positive charges and a separation of this So I've got two identical, let me just bring in what is here. Yeah, so you've got two particles. You've got this particle here and this one. So they are saying they've got this separation. So this is going to be your R. And they are said to be released from rest. So you know most that we have got U. And immediately after the release, particle 1 assumed an acceleration of this. So you've got your A1 there, while particle 2 has got A2. This is going to be your A2. Then they told you that particle 1 has a mass of that. So you are given M1. And then they come and say, find the charge. In other words, you are asked to calculate the value of Q. So since you are told that these two things, they are identical or they are the same, that's why you can see this writer, they came here and said, let Q be equal to Q1, which is equal to Q2. Since they are all the same, so you can just use Q to represent both of them. So now, we know for a fact that Coulomb's law, which says F is equal to Q1 multiplied by Q2 over R squared, is used to calculate the electric force between the two particles. But the same force can also be calculated using Newton's second law, which is F is equal to ma. So you can calculate F between these two particles by using F is equal to ma, like this. So to do that, for you to calculate F associated with this and F associated with that, you can just use F1 is equal to ma, where M1 will be this and A1 will be that. Then you can be able to calculate your F1. For your F2 now, which is equal to M2 and A2. But remember, these two things, they are identical and they are repelling each other. After they were released, they started to repel each other. Ne? Since they all have same positive charge, so they started to repel each other. So what it means is that F1 is going to be equal to F2. So you are going to equate whatever the value that you are going to get for F1 to whatever that you would get when you are calculating F2. By substituting M2, you have got the value of A2. You also put the value of A2. Then you see that M2 will become your unknown there. Then you solve for M2. This is how you get your M2. After getting M2 now, you can be able now to find the value of Q. So in other words, this question, you need to find the mass first for you to be able to then find Q. So how do you find Q? You just come and substitute. Since now you have gotten the value of F1, which you got through this formula, you can now still equate to the normal formula of the Coulomb's law that you know. You know the value of K, you know the value of R. What you don't know is the value of Q, which happens to be Q1 and Q2. So here the writer said, but MA is the, so the force that you have found, which is F1, is this. So you just have to substitute the value of F1 and then equate it to this. After doing that, you know the value of K. So after substituting K, then you need to make Q2 subject of the formula, Q squared, sorry, subject of the formula. This is how you do it. So after making Q squared subject of the formula, this is what you are going to get. But remember, we need the value of Q, which is a charge. So you need to put square root both sides. Then you are going to get your answer. And your answer is going to be plus or minus. And then since the question told you that they are positively charged, you are going to take the positive one. Are we clear, guys?